Right, in Systems of Equations Day 4, we're going to learn how to use the calculator to help us solve matrices. So you'll be seeing a lot of calculator screenshots in this particular lesson. This over here. Alright, so it says find the inverse of matrix A. In doing so, you must begin by finding your matrix button. That's there. Next, you must move to your edit screen and edit matrix A. You have to count the rows and columns to create your matrix. That's a 2 by 2. And you fill in your numbers. 3, enter, 2, enter, 4, enter, 3, enter. Now that your matrix is created, the way that you find the inverse matrix is by quitting out of the matrix screen. Back at your home screen, you retrieve matrix A. That's by going back in, finding names, hitting enter, and X to the -1 key. The inverse key is the matrix key. After you found that, your solution is given as 3, -2, -4, 3. So please fill in your values as 3, -2, -4, and 3. And you can label that as matrix A to the -1. Find the inverse of matrix A before moving on. Right, now that you've found matrix A, let's make sure that you've got it. The way to do it is going back and editing and filling in your values. 5 divided by 6, -7 divided by 6, -1 divided by 3, and 2 divided by 3. Quit out of your matrix screen, back to home screen. Nice trick with the calculator is second entry. That gives you the previous value. It's a shortcut. 4, 7, 2, and 5 should be your matrix. All right. When using matrices to solve systems of equations, the equations must be written in standard form. That is, AX plus BY equals C. The same can be said for example number 5. We'll get to that in a moment, but it's got to be in standard form. If it's not, the matrix will not work. So the way that you set this up is AX plus BY equals C. Your matrix A is going to be the left side of the equation, and your matrix B is going to be the right side of the equation. Do not use variables in the matrix, only use coefficients. Go to the matrix, edit matrix A, fill in your values 4, 5, -1, and -1 and 1. Quit out of the matrix. Get into the habit of quitting out of the matrix, because you will have a habit, if you do that, of not inserting a matrix into the matrix, and believe me, it does not like that one bit. Alright, matrix B is the 2 solutions, so that is a 2 by 1 matrix, and that is -3, enter, 3, enter. Alright, what you're going to do now is you're going to take the inverse of matrix A and you're going to multiply it by matrix B. So your calculator screen will look like this. Quit out of the matrix. Matrix A inversed multiplied by matrix B. The solution matrix is -2, 1. Alright, French roast coffee costs $5.20 per pound and Colombian coffee costs $4 per pound. How much of each kind should be used for a 100-pound mixture that can be sold for $4.72 a pound? Alright, so we want the French roast plus the Colombian coffee to equal 100 pounds. We want the cost of that 100 pounds of coffee. Remember, we're not doing 1 pound of coffee, we're doing 100 pounds of coffee to equal $472. That is equivalent to $4.72 a pound. Alright, matrix A is the left side of the equation, matrix B is the right side of the equation. So, go into your matrix, edit matrix A, that's 1, 1, 5.2, and 4. Quit out of the matrix, back into the matrix, edit matrix B. 2 by 1, so that's going to be 100 and 472. Quit out of the matrix, second entry gets you the previous answer, and we need 60, 40. Okay, now what does that mean? That means that the first variable, f, is 60. That means that the second variable, c, is 40. Therefore, we need 60 pounds of French roast and 40 pounds of Colombian. Alright, number 5. You'll notice that the matrix thrives on structure. Notice that there is not structure in this particular array of values or system of equations. There are missing variables. If you do not account for those missing variables in your matrix, the matrix will not work. So 2x plus 0y plus z equals 12. Please account for all missing variables by using 0. 0x plus minus y plus z equals 3. Please rewrite all of the equations so the variables x, y, and z line up perfectly. Matrix A and matrix B. Down here, we are going to go ahead and edit our matrix. What I like to do is I like to leave my 2 by 1s and 2 by 2s, and now I'll go down to matrix C, and now I'll make my 3 by 3 matrix. It just is easier than having to reset. You don't have to do that if you don't want to. 1, enter, 1, enter, 1, 2, 0, and 1, and 0, negative 1. Please pay attention to your negatives. They need to be accounted for. And 1. Quit out of the matrix. And you'll notice that this ends up becoming a process. And I will now edit matrix 4 which is a 3 by 1 matrix. And that was going to be 0, 12, and 3. Quit out of the matrix, bring back your previous entry, and don't do that, excuse me. Bring back matrix C, inverse it, and bring back matrix D. And there's your solution, 7, -5, and what was it? -2. What does that mean? That means that the first variable x equals 7, the second variable y equals -5, and the third variable z equals -2. Please take a few moments now to complete example number 6. Be ready to share the answers that you get to this particular problem in class tomorrow.